Hi, my name is Angela with Mathnasium. Today we're going to be talking about indirect variation, working through a couple of example problems together using indirect variation. And the first thing that I want to point out when working with indirect variation is our equation that we would use, y equals k over x, y equals k divided by x, where k is our constant of proportionality, can also be called our constant of variation. So let's go ahead and start our first example. If y varies inversely as x and x equals 6 when y equals 3, find y when x equals 4. So our first step here is that we need to solve for our constant of proportionality k. So let's go ahead and do that by plugging in the y and x values that they gave us. X equals 3 and x equals 6 and y equals 3. So we substitute in those values into our indirect variation equation, and we're going to solve for k. And in this case, to solve for k, we're going to want to multiply by 6 on both sides so that we can cancel this out of the denominator, and k is going to equal 18. So now that we know what k equals, we can plug that into our indirect variation equation. 18 over x. And we can plug in x equals 4 so that we can solve for y when x equals 4. So y is going to equal 18 divided by 4, which is 4.5. So that's how we'd solve one of these types of indirect variation problems. Okay, now let's go ahead and start our next example. Alex's average speed is inversely proportional to the time it takes to drive to the beach. If Alex's average speed is 60 miles per hour and he arrives in 3.5 hours, how long would it take if his average speed is 70 miles per hour? So the first thing I want to point out here is this phrase is inversely proportional to. That's what tells us that this problem is an indirect variation problem and that we'd be using this equation up here at the top to solve this problem. Now the next thing is we want to identify our x and y variables here. So let's go ahead and identify those. Our y is going to be our average speed. And our x is going to be the time it takes to arrive at the beach. And just like our last example, our first step is going to be solving for that constant of proportionality k. And to do that, we're going to plug in the x and y values that they give us and solve for the equation for k. So let's identify those. Remember, our y is our average speed, and it tells us here that Alex's average speed is 60 miles an hour when he arrives in 3.5 hours. So we can say y is 60 and x is 3.5. So let's go ahead and plug those in. 60 k over 3.5. And to solve for k here, we're going to multiply by 3.5 on both sides. So we can cancel this out of the denominator, and that gives us k equals 210. So now we can plug in our newfound k value into our indirect variation equation so that we can plug in our 70 miles per hour and solve how long it takes to arrive at the beach if his speed is a little bit higher. So y equals 210x. I just substituted in our k value there. And the question asks, how long would it take if his average speed is 70 miles an hour? Now remember, our y is our average speed here, so we're going to have to substitute our 70 into our y. There we go. And there's a couple of ways we can solve this as an equation. I'll just show you one way to do that. So we want to solve for x here, and what I like to do is I'm going to move my x over by multiplying by x on both sides. That gives us 70x equals 210. And now to solve this, we're going to divide by 70. That cancels on the left. And x is equal to 210 divided by 70, which is just 3. So it will take Alex 3 hours to arrive at the beach if his average speed is 70 miles an hour. Thank you for joining us here today as we went through a couple of indirect variation problems. Please leave a like on our video, and if you have any suggestions for any future math topics that you would like to see covered on our channel, go ahead and leave a comment below with that suggestion. We hope you have a great rest of your week, and we'll see you next time.